Hello everyone, this is the CS Revelation. Welcome to a new video on Java. Today's topic is logical operators. Now Java has three logical operators which respectively stand for AND, OR, and the NOT operator. Now the results of these operators are similar to their meanings in English, and here's a little table that explains it. So an AND operator returns a true if both statements are true. So let's take this example. So if A is true and B is true, then the outcome of the whole expression is true. But if one of these two statements, A or B, is not true, then it will never be true. Then the outcome is going to be false. So the only case that this expression going to return a true if both A and B are true. But if one of them is false, then the whole expression is going to be false. The OR operator returns true if one of the statements is true. So it is enough that one of these two statements, A or B, is true, regardless of the other statement, that the outcome of the whole expression going to be true. So if A is true and B is false, the whole expression will give us a true. And if B is true and A is false, the whole expression going to give us true. If A and B, both of them are true, also is going to give us a true, but the only case that's going to make this expression turn false if A and B are both false. Now, the NOT operator reverses the result. It returns false if the result is true. Now, let's take a look at this example. So, also, I would like to mention that if you ever have to negate an expression that contains logical operators, and you probably will, De Morgan's law can help. So, for example, this expression here, we have not A and B. So it is the same as not. So you're going to reverse the first expression, so not A, and also we're going to have the opposite of AND, which is going to be OR. That is going to be OR, and the negation of B is going to give us not B. So the outcome of this, so the same thing as this, not this whole expression is equivalent to not A, the opposite of AND is OR, and not B. So this expression is the same as this expression. Let's take a look at the negating and OR. Now this one is also the same as we said applying De Morgan's law, we're going to be negating the expressions and also inversing the operators. So the first expression is A, it's going to become not A. And the operator is OR, the inverse of an OR is going to be an AND. And the second expression is B, and the inverse of a B is a not B. So this is how to use the not operator. Now, De Morgan's law also applies to relational operators, and we're going to see that in examples once we start typing code. But I wanted to explain this even further. And the best way really to explain the logical operators is to use gates. So let's take a look at a circuit here. So in this circuit, we have a light bulb and we have two switches. We have switch A and switch B. Now, when both switches are open, that means let's think that if the switch is open, that means it's false. That means A is false. And when the B switch is open, that means B is equal to false. If the switch is closed, then we say that B is equal to true. Now, this is the visualization of the AND operator. So we have expression A and expression B. So the only case that is going to make this light bulb turn on, means this light bulb is lit, is true, if A and B, both switches are closed. That means A is equal to true and B is equal to true. Now notice if only A is closed, that means A is equal to true and B is equal to false, the light bulb is off. It's false. So the outcome of one is true and the second one is false is going to give us a false. Now, if both switches are closed, that means both switches are, or both expressions are equal to true, A is equal to true and B is equal to true, then the outcome of that is going to be a true and the light bulb is on. So again, the AND operator returns true if both statements are true, which is equivalent to an AND gate. Let's take a look at the OR. Now, also that is equivalent to the OR gate. So the two switches here are in parallel, they're not in serial. So this expression A or switch A, if it is false and B is also false, then this light bulb is going to be off. That means false. Now, when is this light bulb is going to be lit? If one of the two switches is closed. That means if one of them is true, then it is enough for the whole expression to be true. That means it is enough for the light bulb to be off. We have a closed circuit here. Now, that is the OR. So we're saying that it returns true. That means it will turn this on if one of the two switches is true. Also, if both switches are closed, that's also going to give us, a true outcome. That means the light bulb is on. And that definitely helps understanding the OR operator. Now let's dig deeper and take a look at some code where these logical operators are applied. Okay, so let's start by practicing the AND operator. So the AND operator is, like we said earlier, that needs both sides on the expression to be true in order for the outcome to be true. If one of the sides is false, the outcome should be false. So for this, let's create 3 Boolean variables. So let's say Boolean A equals true. And let's create a second one that is Boolean B equals false. And let's create Boolean C and we make it equal to true. Now, let's try to print the outcome of A and B. So the expression that we have here is going to be A and B. So system out print ln A and B. So we're using the AND operator here to find out the outcome of A, the expression A, and expression B. Like we said, the AND operator, only if both sides of this statement are true, both are true in order for the outcome to be true. So in this example, A is equal to true, but B is equal to false. So the outcome here, like you guessed it, should be false. So let's find out if it's going to print false. And there you go. Now, let's try an example where we have both sides are true. So if both sides are true, say for example, B and C, so A is true, C is also true, so true and true should give us a true. Now, the outcome of that is true. Okay, so now let's take a look at the OR operator. So the OR operator works in a different way, where if it is enough for one side to be true in order for the whole outcome to be true. Now, let's find out for both of these. Say we want to find out A or B, and also we want to find out A or C. Now, A is true, B is false. So what's going to be the outcome of true or false is going to be true because one of the sides is true. Okay, so let's comment these out just so we only see the result of those two. So this gave us true because A is true, B was false, right? So B is false, A is true. So therefore, one of the sides is enough. One of the expressions is enough to make this whole expression true. The second example here, A or C. C is true and A is true. So automatically, the whole outcome is going to be true. Now, what if both sides are false, then we should get a false. That's the only case you get a false with an or operator, if both sides are false. So say, for example, here B is false. Let's say false or B. So this should give me a false. So I basically put the value there instead of using a variable. So false or B, and B is also false. So that should give me a false. And that is the outcome of this one. True is the outcome of the second one. Okay, now we're going to take a look at the not operator. So negating a logical expression is the same as negating each term and changing the operator. So the first expression that we're going to take a look at is going to be A and B. And then we're going to negate that and see if it's equivalent to negating each expression and also inversing the operator. Okay, so here we're talking about the not operator. So let's comment this out, and what we want now is this expression here. So the first expression is going to be negating this expression. So A and B. Now A is true, B is false. So A and B should give us a false because one of the sides is false. Okay. Now, when we inverse that, when we say not that false, it should give me a true. Okay, so let's only run that one and see if it's going to give me a true. So we got a true here because we inversed the outcome of this statement. So it's A and B, and not that is going to be the opposite. Now, earlier I told you that this is similar to inversing each statement. So it's going to be not A, and inversing the operator, which is and, becomes an or, and this is C, becomes a not C. So these two are equivalent now, and they should both give me a true. Let's see. No, this is a B, sorry. Yep. So the same expression. So this, both of them will give me a true. So true for this statement and true for this statement. Okay, now let's take a look at applying the not operator onto relational operators. So the less than, greater than, and so on. It turns out that De Morgan's law also applies to these relational operators, and negating each term simply means just using the opposite relational operator. Okay, now let's take a look at negating relational operators. Like I said earlier, that De Morgan's law also applies to relational operators, and negating each term means using the opposite relational operator. So if we have a less than, it should become greater than or equal. Or if we have greater than, it should become less than or equal. And if we have equals, it should become not equals. Okay, so here we're talking about relational. So it is negating relational operators. So negating relational operators. Okay. So for this, we're going to need let's say two variables of type integer. So let's say int x. I'm going to make it equal to 2. Then int y, and I'm going to make it equal to 5. Now, when negating relational operators, we're going to be applying De Morgan's law, and it's the negation of each of those relational operators is going to result in giving us the opposite of that relational operator. So for example, if we have the strictly less than, it's going to become greater than or equals. That is the opposite. Or if we have strictly greater than, the opposite of that is going to be less than or equals. If we have equals, that means two expressions are equals, the opposite of that is not equals. Okay, so and also vice versa. If you had the expression that is greater than or equals, the opposite of that is strictly less than. And if you had this expression, which is less than or equals, the opposite of that is strictly greater than. Now let's use some expressions and find out if they do generate the same outcome. So for example, if we have, let's say the following expression, x strictly less than y, and let's say the outcome of that is equal to true, right? So technically here we're saying is 2 strictly less than 5, okay? Is x strictly less than y, is 2 strictly less than y, and the outcome of that is true. Now, let's apply the not operator. That means we're going to inverse this expression. So I simply type the not operator and put my expression. So that's going to be x strictly less than y. Now let's find out if this is going to be the inverse of true, which is false, right? So there you go, you got false because this is the inverse of this. Now I also said that when simplifying this expression, the inverse, it's basically equivalent to inversing the relational operator. So it should be then equal to x greater than or equal to y, right? So when running this, it should give me the same outcome. So this expression should give me the same outcome as this expression. And that should be a false as well. So we got 2 falses here. And that is because the inverse of an expression that has a relational operator should have the opposite relational operator in it. Now let's use a more composite expression that includes logical operators and relational operators. Say, for example, we have the following expression. Say we have this expression here. So we have x strictly less than y, and y is equal to 3, right? So this is the expression that we're trying to find out its outcome. Now, if we were to trace this expression or the outcome of this expression, so the first statement here that says x is strictly less than 5, is that true? So x is equal to 2. Is 2 strictly less than 5? Yes, so that is true. Now, and we add the and operator here. So we have the next expression, which is y equals to 3. Now, is y equals to 3? Y is equal to 5, so that means the outcome of that one is false. Now, we simplify this further. Is true and false going to have an outcome? What's the outcome of true and false? Like we learned in the previous slides, that true and false will give us a false because it only gives true if both sides are true, because we have a logical operator that is an and. Okay, so let's find out if this is going to give, like we said, this should give an outcome that is false. Okay, so I'm going to comment these out just so we get just one print out. So like I said, this should have an outcome that is true. So when we run this, we get a false. Sorry, we said, like I said, we should have an outcome that is a false, and we got a false. That is because this expression is true, this expression is false, and true and false gives a false as an outcome. And that's what we got here. Now let's find out how to negate this expression. Now, the expression again, let's just copy this and negate it. And let's find out if it gives me the opposite outcome. Okay, so the not this statement, that means we are inversing this statement, should give me a true, because the opposite of a false is a true. Okay, so when I run this, I get false for the first expression. The inverse of false is true. Now, like I said earlier, I'm going to simplify this one and find out if it's also going to give me a true. I'm going to simplify this expression with the not operator. So this expression here Now, when negating this expression and simplifying it, we are looking at one whole expression. So we're going to do it one sub-expression at a time. So x less than 5. So not x less than 5 should become x greater than or equals, right? So the opposite of this is equal to this. And then we get to the logical operator and the opposite of and is an or. Then we have this expression, which is x is equal to 3, and the opposite or the inverse of x equal to 3 is y is not equal to 3. So when we run this, we should get it true because these two are equivalent, just that we turned it into this format. Okay, so that is how you would inverse relational and logical operators. Again, let me just sum up, is that the inverse of a logical operator, if you have an and, it becomes an or. And the inverse of a relational operator, if you have a strictly less than, it becomes greater than or equals. If you have an equals, it becomes not equals. Okay, this is the end of this video. I'll see you in the next one. Peace.